September 3, 1943. Kriegsmarine Headquarters, Berlin. Admiral Karl Donitz stared at the reconnaissance photographs spread across his mahogany desk with an expression that his chief of staff, Conter-Admiral Eberhard Gott, would later describe as resembling a man confronting evidence of his own irrelevance. The images showed American cargo vessels unloading supplies directly onto Sicilian beaches at a rate that contradicted every principle of naval logistics that the German Naval Command had refined through 4 years of total war. According to verified intelligence reports cross-referenced with aerial reconnaissance, the Americans were delivering an average of 2,000 tons of supplies daily to beaches that possessed no port infrastructure, no established supply depots, and no protection from the elements that had governed maritime logistics since the age of sail. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. The German naval establishment had spent the previous 18 months systematically analyzing American industrial capacity and maritime capabilities, producing assessments that ranged from dismissive to contemptuous. These were not casual judgments but carefully calculated evaluations based on intelligence gathered from multiple sources including neutral shipping reports, signals intelligence, and assessments from German technical experts who had studied American shipbuilding before the war. The consensus was unanimous and unequivocal. American naval logistics represented a fundamental weakness that would cripple their ability to project power across the Atlantic. The Americans possessed neither the merchant fleet capacity nor the maritime expertise to sustain large-scale operations in Europe. Their shipbuilding industry, while large in absolute terms, was oriented toward commercial vessels that prioritized economy over the military specifications required for wartime operations. Their navy, though expanding rapidly, lacked the operational experience that came from generations of maritime tradition. Most critically, American logistics doctrine appeared to assume the availability of established port infrastructure that would not exist in contested amphibious operations. Admiral Donitz had personally authored a strategic assessment in January 1943 that had been distributed throughout the Kriegsmarine Command structure. The document, recovered from German naval archives after the war, laid out what appeared to be irrefutable logic about American limitations. The memorandum began with fundamental principles of maritime logistics that had governed naval operations since the age of wooden ships. Cargo vessels required protected harbors for efficient unloading. Sustained military operations demanded supply throughput that only established ports could provide. Amphibious operations were inherently vulnerable during the critical period before port facilities could be captured and made operational. The assessment then applied these principles to American capabilities with devastating conclusions. American merchant vessels were designed for port-to-port operations and lacked the specialized equipment for beach landings. American logistics planning assumed supply rates that required functioning port infrastructure. American forces would face a critical vulnerability during the weeks or months required to capture and repair major ports. Any competent defense could exploit this weakness by denying port access and forcing Americans to attempt sustained operations through improvised beach logistics, which historical precedent showed to be impossible at the scale modern warfare required. The strategic implications seemed clear and were embraced throughout German military planning. American forces might achieve initial landings through overwhelming naval and air superiority, but they would quickly face supply crises that would stall offensive operations. German forces could trade space for time, withdrawing from beaches while denying port access, confident that American logistics would collapse before significant territorial gains could be consolidated. The longer supply lines stretched from American-controlled ports, the more vulnerable American operations would become. This assessment informed German defensive strategy across the Mediterranean and shaped planning for the anticipated invasion of France. The German High Command was preparing to defend a fortress Europe based partly on confidence that American logistics would prove incapable of sustaining the massive supply requirements that modern mechanized warfare demanded. Conter-Admiral Gott had been among the most vocal proponents of this strategic assessment. A career naval officer who had served in World War I and had spent 2 decades studying maritime logistics, Gott possessed credentials that made his judgments authoritative. He had written extensively about the mathematical constraints governing naval supply operations. His pre-war academic work had examined historical amphibious operations from Gallipoli to Norway, identifying consistent patterns where logistics limitations determined operational outcomes regardless of tactical success. When Gott spoke about the impossibilities of beach logistics, he spoke with the authority of rigorous analysis backed by historical precedent and technical expertise. In a May 1943 staff conference, Gott had presented calculations that seemed to settle any debate about American logistics capabilities. His presentation, documented in meeting minutes discovered in captured German files, walked through the mathematics with precision that left no room for optimistic interpretation. A single infantry division in active combat required approximately 300 tons of supplies daily to maintain operations. This included ammunition, fuel, food, medical supplies, and the 1,000 other necessities that modern warfare consumed. An armored division required 500 tons daily due to massive fuel consumption and ammunition expenditure. A corps of 3 divisions therefore required minimum 1,000 tons daily, and this assumed efficient operations with minimal waste. American forces had landed multiple corps in Sicily, which meant they required several thousand tons of supplies daily to sustain operations. Delivering this tonnage through beach operations without port facilities presented problems that got calculated as mathematically insurmountable. The detailed analysis that followed demonstrated why beach logistics could not possibly support these requirements. Cargo vessels required an average of 18 hours to unload using conventional methods with port infrastructure. Without ports, unloading times would extend dramatically, perhaps to several days per vessel. Weather conditions in the Mediterranean made beach operations impossible approximately 30% of the time due to wave action. Beach approaches could accommodate only limited numbers of vessels simultaneously due to space constraints and tidal considerations. Cargo transferred from ships to beaches still required transportation inland, adding another layer of logistical complexity. When Gott ran the calculations, the conclusion appeared inescapable. Beach logistics might support small-scale operations for limited periods, but could not possibly deliver the thousands of tons daily that American forces required for sustained offensive operations. The Americans were attempting something that violated fundamental constraints of maritime logistics, and reality would inevitably enforce those constraints regardless of American industrial capacity or determination. The German Naval Intelligence Service, the Marienachrichtendienst, had produced supporting analysis that appeared to confirm these assessments. Intelligence officers had carefully tracked American merchant ship production and had identified what they considered fatal weaknesses in American maritime strategy. The Americans were indeed building merchant vessels at unprecedented rates, but these vessels were of a standardized design that German experts considered fundamentally unsuitable for military logistics. The ships that would later become famous as Liberty ships were being constructed using welding techniques rather than traditional riveting, a choice that German naval architects viewed as compromising structural integrity for production speed. The vessels were designed for simplicity and rapid construction rather than for the durability and specialized capabilities that military operations required. They possessed minimal defensive armament, slow speeds that made them vulnerable to submarine attack, and cargo handling equipment that assumed port infrastructure would be available. Korvettenkapitän Hans Weber, a naval intelligence analyst specializing in enemy industrial capacity, had written a detailed technical assessment of Liberty ship design that circulated among German naval staff. The report, recovered from German archives, contained analysis that seemed definitive to officers trained in traditional maritime engineering. Weber noted that Liberty ships were constructed using prefabricated sections welded together, a technique that created potential weak points at weld joints. The vessels were powered by relatively simple reciprocating steam engines rather than more sophisticated turbines, limiting their speed to approximately 11 knots, barely faster than a World War I cargo ship. Their cargo holds were configured for standard commercial loading, lacking the specialized equipment that would be needed for rapid unloading in austere conditions. Most damning, the ships were designed with projected service lives of only 5 years, suggesting that even the Americans recognized these vessels as temporary expedients rather than serious maritime assets. Weber's assessment concluded with what seemed like obvious logic. The Liberty ship program represented American industrial capacity applied without naval expertise. The Americans could indeed build ships quickly, but they were building the wrong ships. Quantity could not compensate for fundamental design inadequacies. These vessels might serve for protected convoy operations in the Atlantic, but they could not solve the fundamental problem of how to deliver massive tonnage to forces operating without port access. German U-boats would sink substantial numbers of these poorly defended, slow-moving targets, and those that survived the Atlantic crossing would prove incapable of supporting sustained amphibious operations. The Liberty ship program was, in Weber's assessment, a massive misallocation of resources that would ultimately prove American industrial capacity was no substitute for maritime competence. This institutional conviction that American logistics was fundamentally inadequate had been reinforced by German experiences observing Allied operations in North Africa. The British had required months to build up supply capacity after securing ports in Egypt and Libya. Allied operations in Tunisia had been constrained by logistics challenges that limited offensive tempo. When the Allies invaded Sicily in July 1943, German commanders expected to see familiar patterns of American forces achieving initial success followed by logistics-driven operational pauses as supplies accumulated slowly through captured ports. The German strategy for defending Sicily had been built around this assumption, trading immediate territorial defense for longer-term logistics attrition. The reality that confronted German intelligence in late August and early September 1943 contradicted every element of this analysis. American forces were not experiencing predicted supply constraints. They were not pausing operations while waiting for tonnage to accumulate. They were not struggling with the beach logistics that German experts had calculated to be impossible. Instead, reconnaissance reports and signals intelligence indicated that American supply operations were functioning with efficiency that exceeded what German forces achieved using established port facilities and internal European rail networks. The photographs on Admiral Donat's desk captured scenes that seemed to defy physical possibility according to German understanding of maritime logistics. The images showed dozens of cargo vessels positioned offshore, with smaller landing craft shuttling continuously between ships and beaches. On the beaches themselves, supplies were stacked in organized dumps that extended hundreds of meters inland. Trucks moved in constant streams from beach areas toward forward positions. The scale of operations visible in these reconnaissance images represented throughput that German experts had deemed impossible without port infrastructure. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. What made these images particularly troubling was that they represented not peak capability under ideal conditions but sustained operations across weeks of continuous activity. German intelligence had observed American beach operations through multiple weather cycles, including periods when wave conditions should have made unloading impossible. Yet the supplies continued flowing with consistency that suggested the Americans had solved problems that German maritime expertise considered unsolvable. The reconnaissance photographs documented not just the existence of American beach logistics but its apparent reliability and scale. Admiral Donats had summoned his senior staff not to discuss whether the intelligence was accurate, as multiple independent sources confirmed the same patterns, but to understand how American achievements were possible. The meeting that followed would later be recognized as marking the moment when German naval leadership began comprehending that they were facing not just quantitative American advantages in industrial production but qualitative innovations in logistics that represented conceptual breakthroughs the Germans had not anticipated. Counter-Admiral Gott opened the discussion by reviewing what German intelligence had definitively established about American operations. The facts were documented through multiple collection methods and were not reasonably disputable. American forces in Sicily were receiving between 1,500 and 2,000 tons of supplies daily through beach operations. This tonnage was being delivered with sufficient reliability that American forces showed no signs of the supply constraints that should have limited their operational tempo. The supply flow was being maintained despite weather conditions that periodically made beach approaches difficult. Most remarkably, the Americans appeared to be achieving these results while simultaneously preparing for additional amphibious operations, suggesting their beach logistics capability was not a one-time achievement but a repeatable system. Gott then addressed the question that dominated the meeting. How were the Americans accomplishing what German analysis had deemed impossible? The available evidence suggested several factors that German planning had not adequately considered. First, the Americans were using specialized landing craft in much larger numbers than German intelligence had estimated. These vessels, designated LSTs, LCIs, and various other configurations, were designed specifically for beach operations and could deliver cargo directly from ships to shore without requiring port facilities. German intelligence had been aware these vessels existed but had underestimated both their numbers and their capabilities. Second, the Americans had developed systematic procedures for beach operations that treated the beach itself as a temporary port with organized traffic control, designated unloading zones, and coordinated movement of supplies inland. German observers had assumed beach operations would be chaotic and inefficient, but reconnaissance indicated the Americans had imposed industrial organization on what German doctrine treated as improvised expedient operations. The beaches functioned as organized logistics hubs rather than as desperate improvisations. Third, and perhaps most significantly, the Americans were operating under weather conditions that German maritime doctrine would have considered prohibitive for beach operations, yet they were maintaining supply flow with only modest reductions during rough weather. This suggested either that American vessels had capabilities German experts had not recognized or that American operational procedures included techniques for working in conditions German doctrine avoided. Either explanation indicated that American maritime capabilities were substantially more sophisticated than German assessments had credited. Fregattenkapitän Reinhard Müller, who served as the Kriegsmarine's liaison to the Army High Command, raised the question that would dominate German strategic thinking for the remainder of the war. If the Americans could sustain multiple corps through beach logistics in Sicily, what would they be capable of accomplishing when they inevitably invaded France? The Sicily operation involved relatively short supply lines from North African bases and operated in the relatively calm Mediterranean Sea. An invasion of France would involve longer supply lines across the Atlantic and operations in the more challenging conditions of the English Channel and Atlantic coast. Yet if American beach logistics could deliver 2,000 tons daily in Sicily, German planners could no longer assume that the absence of ports would meaningfully constrain American operations in France. The strategic implications were profound and deeply troubling for German defensive planning. The entire strategy for defending Fortress Europe assumed that Allied forces would require major ports to sustain invasion forces, which meant German defenses could focus on port cities and could trade territory in other areas, knowing that Allied logistics would eventually create operational constraints. If the Americans could sustain major operations through beach logistics, then German forces would need to defeat invasion forces immediately at the beaches because the expected logistics constraints would not materialize to assist German defensive operations. Admiral Donitz concluded the meeting by ordering comprehensive reassessment of American maritime logistics capabilities. The analysis that had seemed definitive 6 months earlier was clearly incomplete or flawed in fundamental ways. German naval intelligence needed to understand not just what the Americans were accomplishing but how they were doing it, because German defensive strategy for the invasion of Europe depended on accurate assessment of American logistics limitations. The problem was that time was limited and German intelligence collection capabilities were becoming increasingly constrained as Allied air superiority made reconnaissance more difficult and costly. The September 3 meeting represented a watershed moment in German understanding, but it came too late to fundamentally alter German strategic planning. The invasion preparations for defending France were already well advanced and based on assumptions about Allied logistics limitations that were proving incorrect. German forces would need to execute defensive operations based on flawed assessments because the recognition of error came too late to develop and implement alternative strategies. What German commanders did not yet understand was that the Liberty ships they had dismissed as unsuitable for military logistics were only part of a comprehensive American system that included not just the ships themselves but specialized landing craft, systematic beach operations procedures, innovative cargo handling equipment, and logistical planning that approached industrial precision rather than military improvisation. The Americans had not merely built more ships but had reconceptualized maritime logistics in ways that German naval tradition had not imagined possible. The Liberty ship program that German experts had analyzed as a technical failure was succeeding precisely because American planners had different design objectives than German analysts assumed. The ships were not intended to be sophisticated naval vessels but were designed as simple, mass-producible cargo carriers that could be built faster than U-boats could sink them. Their welded construction, which German experts criticized as structurally weak, actually enabled rapid production using semi-skilled labor rather than requiring the specialized shipyard craftsmen that traditional riveted construction demanded. Their simple engines, which German analysts noted were technologically backward, were chosen because they could be manufactured quickly using existing industrial capacity rather than requiring specialized marine engineering facilities. Most significantly, Liberty ships were designed as components of a logistics system rather than as independent vessels. They worked in coordination with specialized landing craft that could transfer cargo from ship to shore. They operated according to systematic scheduling that treated Atlantic crossings like railroad operations with vessels departing on fixed schedules. They carried cargoes that were carefully planned and loaded according to priority of need rather than simple space efficiency. The entire system represented industrial logistics principles applied to maritime operations, and it worked precisely because the Americans were willing to abandon maritime traditions in favor of systematic efficiency. The German naval establishment, trained in centuries of maritime tradition and proud of its technical expertise, had evaluated Liberty ships according to traditional naval architecture standards and had concluded they were inadequate. This assessment was correct according to the standards applied but irrelevant to the actual challenge the Americans were solving. The Americans were not trying to build better ships by traditional standards but were redesigning the entire logistics system to eliminate the need for traditional naval architecture. It was a classic case of competing paradigms where the side operating under old assumptions failed to recognize that the rules had changed. As autumn 1943 progressed and German intelligence accumulated more data about American logistics operations, the scale of German miscalculation became increasingly apparent. The Americans were not just marginally exceeding German predictions but were operating at multiples of what German experts had calculated as theoretical maximums. Beach operations that German doctrines said could support perhaps 500 tons daily were delivering 2,000 tons. Supply chains that German planning assumed would require weeks to establish were becoming operational in days. The consistency and reliability of American logistics suggested not lucky improvisation but systematic capability that could be repeated and scaled. The psychological impact on German military leadership was substantial and demoralizing. For 4 years, German forces had achieved remarkable operational successes despite facing enemies with superior resources by exploiting superior operational skill, tactical flexibility, and efficient logistics. The German military had prided itself on doing more with less through excellence in execution. The realization that American forces could simply overwhelm German operational advantages through systematic application of industrial capacity represented a fundamental challenge to German military identity and confidence. Counter-Admiral Gott, whose logistics calculations had helped shape German strategy, later wrote in his post-war memoirs about the impact of recognizing the magnitude of German miscalculation. The professional humiliation was significant but secondary to the strategic horror of understanding that German defensive planning had been based on assumptions that were catastrophically wrong. If American logistics could deliver 2,000 tons daily through Sicilian beaches, what would they deliver through French beaches with shorter supply lines from Britain? If Liberty ships that German experts dismissed as inadequate were supporting these operations, what would happen when American shipbuilding reached its projected peak production? The Germans had planned to fight a defensive campaign that exploited Allied logistics limitations, but those limitations appeared far less constraining than German planning had assumed. The final reports from the September Intelligence Review made clear that German naval assessment had fundamentally misunderstood American capabilities. The Liberty ship program that looked like industrial inefficiency to German maritime experts was actually systematic innovation that prioritized production scale over individual vessel sophistication. The beach logistics operations that German doctrine considered impossible were functioning efficiently because Americans had designed systematic procedures that German maritime tradition had never contemplated. The supply throughput that German mathematics calculated as unachievable was being exceeded because American logistics operated according to different principles than the German calculations assumed. Admiral Donitz ordered his staff to prepare revised assessments of Allied invasion capabilities for distribution to German forces preparing defenses in France. The new analysis would need to inform German commanders that they could not rely on Allied logistics constraints to limit invasion operations. American forces would be capable of sustaining major operations directly through beach logistics for extended periods. German defensive strategy would need to defeat invasion forces at the waterline because the operational pause that German planning anticipated would not occur. The Americans had solved the fundamental problem that German strategy had assumed would remain unsolvable. The transformation that would ultimately render German naval assessments obsolete had begun not in shipyards or naval architecture offices, but in an unlikely location that German intelligence never identified as strategically significant. In December 1940, 18 months before Pearl Harbor brought America into the war, a meeting took place in a nondescript office building in Washington, D.C. that would eventually reshape the entire strategic calculus of maritime logistics. The participants were not admirals or shipbuilders but industrial planners, production engineers, and civilian administrators tasked with preparing American industrial capacity for a war that most Americans still hoped to avoid. William Knudsen, a Danish immigrant who had risen to become president of General Motors before being recruited to head the National Defense Advisory Commission, sat across from Admiral Emery Land, who directed the United States Maritime Commission. The two men represented fundamentally different approaches to the challenge of expanding American maritime capacity. Land embodied traditional naval thinking with decades of experience in ship design and naval operations. Knudsen represented industrial mass production principles developed in automobile manufacturing, where he had overseen production systems that built thousands of vehicles daily using standardized components and systematic assembly processes. The strategic problem they faced was both urgent and seemingly insoluble according to conventional maritime wisdom. Britain was losing merchant ships to U-boat attacks faster than British shipyards could replace them. Without massive expansion of merchant fleet capacity, Britain would eventually lose the ability to import the food, fuel, and materials necessary to continue fighting. American shipyards, while substantial by civilian standards, were sized for peacetime commercial construction and lacked the capacity to build ships at rates that would offset German submarine warfare. Traditional shipbuilding required skilled craftsmen who had served apprenticeships lasting years and used construction techniques that had evolved gradually over centuries. The number of trained shipyard workers was essentially fixed in the short term, and ships built using conventional methods required 8 to 12 months from keel laying to launch even under optimal conditions. Admiral Land had spent months working with established shipyards to increase production, achieving modest improvements through extended work hours and deferred maintenance on yard facilities. His projections showed that American yards might eventually reach production of perhaps 100 ships annually by 1943 if expansion programs proceeded successfully and if sufficient skilled labor could be recruited and trained. This represented meaningful improvement over peacetime production but fell far short of the replacement rates that strategic analysis indicated would be necessary. Land's assessment reflected the considered judgment of maritime professionals who understood the genuine constraints that governed ship construction according to established practices. Knudsen listened to Land's projections and delivered an assessment that naval professionals would later describe as either visionary or naive depending on their perspective. The industrial engineer understood that Admiral Land was describing constraints that were real within the framework of traditional shipbuilding but that were not physical laws requiring acceptance. Knudsen had spent his career identifying manufacturing constraints and then redesigning production processes to eliminate those constraints rather than accepting them as immutable limitations. His question to Admiral Land was simple but revolutionary in its implications. If we designed ships specifically for rapid mass production rather than for optimal maritime performance, could we build them fast enough to matter? The proposal that emerged from subsequent discussions represented such a departure from naval architecture tradition that maritime professionals initially dismissed it as technically ignorant. Knudsen proposed building ships using welding rather than riveting, prefabricating major sections in locations away from shipyards, using simple reciprocating engines that could be manufactured by companies with no shipbuilding experience, and designing the entire vessel for assembly by semi-skilled workers rather than requiring traditional shipyard craftsmen. The design would prioritize simplicity over sophistication, standardization over optimization, and production speed over individual vessel quality. Naval architects raised immediate and substantial objections grounded in genuine technical concerns. Welded construction created continuous stress points that could lead to catastrophic structural failure, particularly in the cold North Atlantic where steel became brittle. Prefabricated sections required precision tolerances that were difficult to achieve and would create assembly problems when sections arrived at shipyards with dimensional variations. Simple engines meant slower vessels that were more vulnerable to submarine attack and less efficient in fuel consumption. Most fundamentally, the entire approach violated the principle that ships were complex engineering achievements requiring sophisticated design and skilled construction by experienced maritime craftsmen. Henry Kaiser, a Western industrialist with no shipbuilding experience but with remarkable achievements in large-scale construction projects including Grand Coulee Dam, emerged as the unlikely champion of this revolutionary approach. Kaiser had built his reputation on completing massive projects ahead of schedule and under budget by applying industrial production principles to work that others approached as custom engineering. His proposal to the Maritime Commission in January 1941 seemed absurd to established shipbuilders. Kaiser claimed he could build shipyards on the Pacific coast that would produce cargo vessels using assembly line techniques, completing ships in months rather than the year or more that traditional construction required. The detailed proposal that Kaiser submitted revealed thinking that departed from shipbuilding tradition at every level. Rather than building ships sequentially where each vessel was constructed from start to finish before beginning the next, Kaiser proposed building multiple ships simultaneously with different sections of each vessel progressing through specialized workstations. Instead of having skilled craftsmen perform all tasks on each ship, Kaiser planned to train workers in specific repetitive tasks that required less skill but could be performed more rapidly through repetition and specialization. Rather than constructing ships in traditional dry docks, Kaiser proposed building them on open slipways where multiple vessels could be under construction simultaneously. The German Naval Intelligence Service, which monitored American maritime developments through various sources including neutral shipping journals and technical publications, noted Kaiser's shipbuilding plans with a mixture of awareness and dismissal. Intelligence reports from early 1941 acknowledged that Americans were attempting to expand merchant ship production through industrialized construction methods but assessed that these attempts would likely fail or produce vessels of questionable seaworthiness. A March 1941 analysis from the Marine-Nachrichtendienst concluded that American shipbuilding expansion would prove disappointing because the Americans were attempting to apply automotive production principles to a fundamentally different type of construction that required maritime expertise they lacked. This assessment reflected genuine expertise in traditional shipbuilding but failed to recognize that Kaiser and his associates were not attempting to build better traditional ships but were redesigning the entire production system to enable a fundamentally different approach. The first Kaiser shipyard at Richmond, California began construction in December 1940 and launched its first vessel in April 1941, completing the ship in just over 6 months. This timeline was impressive by conventional standards but still insufficient to achieve the production rates that strategic requirements demanded. Kaiser's real innovation would emerge not from building ships quickly but from systematically analyzing and optimizing every element of the construction process. Todd Bath Iron Shipbuilding Corporation in Maine had developed the basic design that would become the Liberty ship, adapting a British tramp steamer design for American production. The vessel that emerged from this design process embodied the systematic simplification that made mass production possible. The ship was 441 feet long, 57 feet wide, and displaced 14,000 tons when fully loaded. Its 5 cargo holds could carry 10,000 tons of freight in standardized packaging. The design intentionally avoided complexity that would slow production or require scarce skilled labor. The construction process that Kaiser and other builders developed for these vessels represented systematic deconstruction of traditional shipbuilding into component tasks that could be performed by workers with minimal training. The hull was divided into prefabricated sections that were manufactured in facilities away from shipyards by workers who never saw complete ships but became highly efficient at producing their specific components. These sections, some weighing 70 tons, were transported to shipyards where they were welded together using techniques that were revolutionary in their scale even if not in their fundamental principles. Welding technology itself was not new, but its application to major ship construction represented a departure that naval architects viewed with considerable skepticism. Traditional riveted construction distributed stress across thousands of individual rivets, which meant that damage or failure of individual fasteners did not threaten overall structural integrity. Welded construction created continuous joints that could in principle be stronger than riveted connections but that also created continuous stress paths where cracks could propagate across entire sections. Maritime engineers understood that metal fatigue and stress concentration at weld points represented genuine risks, particularly in the harsh conditions of North Atlantic service. These concerns were not theoretical but were validated in early 1943 when several Liberty ships experienced catastrophic structural failures, including 3 vessels that broke completely in half while at sea. These failures seemed to confirm the warnings that naval architects had issued about welded construction and provided ammunition for critics who had argued that the Liberty ship program sacrificed safety for speed. German intelligence seized on these failures as evidence that American shipbuilding expansion was producing inferior vessels that would prove unable to withstand operational demands. A March 1943 assessment from German naval intelligence concluded that Liberty ship structural failures vindicated German predictions that American mass production methods would prove unsustainable. What German analysts failed to recognize was that American industrial culture approached failures differently than traditional maritime culture. Rather than treating structural failures as confirmation that the basic approach was flawed, American engineers analyzed the failures systematically to identify root causes and implement corrections. Constance Tipper, a British metallurgist, led investigations that determined the failures resulted from specific combination of factors including poor quality steel, stress concentration at square hatch corners, and embrittlement of steel in cold temperatures. Each factor was addressable through design modifications and improved production procedures. The systematic response to these structural failures demonstrated the advantage of approaching shipbuilding as an industrial process rather than as traditional craft. American builders implemented multiple modifications including redesigned hatch corners with rounded edges to reduce stress concentration, improved steel specifications to ensure adequate toughness at low temperatures, installation of crack arrestor straps at critical stress points, and enhanced welding procedures and welder training to improve joint quality. These modifications were implemented across all yards through standardized engineering changes, and subsequent structural failures dropped to statistically negligible rates. The production process itself evolved rapidly through systematic optimization that would have been impossible in traditional shipbuilding culture. Kaiser and other builders tracked construction time for every major task and every component assembly, identifying bottlenecks and implementing improvements in continuous cycles. Prefabrication of components moved increasingly further from final assembly, with some sections being manufactured in facilities hundreds of miles from shipyards by workers who had never seen ocean water but who became remarkably efficient at producing their specific components to exact specifications. The assembly process at shipyards became increasingly sophisticated as builders gained experience and implemented improvements. Multiple cranes working in coordination lifted huge prefabricated sections into position where welding crews joined them with techniques that became more refined and faster through practice and procedural improvements. The time required to construct Liberty ships fell dramatically as builders moved down the learning curve. Early vessels required 8 months from keel laying to launch. By late 1942, average construction time had fallen to 3 months. In extraordinary demonstrations of capability, Kaiser's Richmond Yard completed the Robert E. Peary in just 4 days and 15 hours from keel laying to launch, though this record-setting construction was deliberately organized as a morale and publicity achievement rather than representing sustainable production pace. The sustainable production rates that American yards achieved were what truly mattered strategically, and these rates defied German predictions even after accounting for the publicity-driven record attempts. By 1943, American shipyards were completing an average of 3 Liberty ships daily, with production peaking at 140 ships per month. This represented construction rates that exceeded German U-boat sinking rates even during the most successful periods of submarine warfare. The strategic mathematics of the Atlantic battle shifted fundamentally when Allied construction capacity exceeded German sinking capacity, and this shift occurred earlier and more decisively than German naval planners had thought possible. The scale of American production created its own strategic effects beyond simply replacing losses. The availability of shipping capacity enabled Allied military planning that would have been impossible with constrained maritime resources. Operations could be planned with confidence that shipping would be available because the maritime constraint that had limited military planning throughout history was being systematically eliminated through industrial capacity. German defensive planning that assumed Allied operations would be limited by shipping scarcity was being undermined by American shipyards that produced vessels faster than German forces could sink them. The Liberty ship program ultimately produced 2,700 vessels between 1941 and 1945. Representing roughly 30% of all American maritime construction during the war. These ships carried approximately 75% of all cargo shipped overseas during the war years, delivering the equipment, supplies, and materials that sustained Allied military operations across multiple theaters. The mathematics were straightforward and strategically decisive. Each Liberty ship could carry 10,000 tons of cargo. 2,700 ships represented 27 million tons of cargo capacity. This capacity enabled simultaneous major operations in Europe and the Pacific that would have been logistically impossible with constrained shipping. The workforce that built these vessels was itself revolutionary in composition and represented social changes that extended far beyond maritime construction. Shipyards that had employed exclusively male workers recruited hundreds of thousands of women who proved entirely capable of performing welding, assembly, and other tasks that tradition had reserved for men. African Americans gained access to industrial employment at unprecedented scales, though often in segregated work units that reflected broader American social patterns of the period. The wartime shipbuilding workforce reached peak employment of 650,000 workers in 1943. Representing expansion from approximately 50,000 workers in pre-war shipyards. Training systems developed to convert inexperienced workers into productive shipbuilders in weeks rather than the years that traditional apprenticeships required. The training focused on specific tasks that workers would perform repetitively rather than attempting to create broadly skilled craftsmen. This narrow specialization was anathema to traditional craft culture but proved remarkably effective at creating productive capacity rapidly. Workers became highly proficient at their specific tasks through repetition and developed efficiency through practice that traditional training systems could not match in speed of skill acquisition. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.